Hello, my name is Jeremy Hunter, and I am the Managing Director of Asset Management for the Indiana Department of Transportation. Today, I will be sharing a little more information regarding our Safety Performance Management program. Our program really is a three-stage process. There are three key components that make up our program. The first is leadership, the second is assessment, and the third is mitigation. Regarding our leadership stage, this is when our executive leadership establishes our agency goals related to what our safety performance targets should be. Some of these are big picture goals, but most of them are intended to be SMART goals that are directly measurable with specific timelines. The second stage is the assessment stage. In this stage, we take the goals that are established by our leadership, we assess how our network is performing, and determine the current risks and opportunities within our network. The third stage is the mitigation stage. In this stage, we develop mitigation strategies for those identified risk and opportunity items. A part of this is to leverage innovation to reach stretch goals for those opportunities, and also to just find ways to evolve our ability to improve our safety faster and more efficiently. So for the first component of our performance management program, the leadership sets SMART goals. So for 2024, our goals that are established were to reduce fatalities and incapacitating injuries on Indiana roadways by 25% for the next 10 years. Next goal was to reduce work zone incidents by 5% in 2024. The third goal is to work in partnership with local governments to prevent injuries and loss of life. These goals actually appear in every employee's work plan. So these goals are something that we will all be evaluated on at the end of the year. Another component of our assessment stage consists of a detailed look at how our system is performing. By analyzing the data, we are able to determine where our greatest opportunities are for improvements. We have routine reporting that is shared with the agency so that we can continually monitor how our system is performing relative to safety. As an example, one area of opportunity is lane departures. If you look at lane departures in the reports that I just showed, lane departures account for 47% of crashes with injuries on local rural roads, and 35% on state rural roads. After analyzing this crash data, we were able to create heat maps like the maps that you see below, highlighting the hotspots where we have higher numbers of crashes in each 1 mile segment. Once we have those areas highlighted, we can evaluate those locations to determine what criteria maybe exist in those areas that could be contributing to the crashes, and then we can start to focus on mitigation solutions. In the example of lane departures, common mitigation measures we would consider would be rumble stripes, improved signage, or geometric improvements. Most of what I have shared is probably very similar to your safety programs. Now I'll share a little bit about some of the exciting innovations that are quickly enhancing our ability to improve the performance management of the safety of our network. With the proliferation of vehicle sensor data, our vehicles now know more about our roadway than we do. Leveraging the insight that could be gleaned from this data is a transformative approach to performance management that our DOT, along with probably many of your DOTs, is quickly looking into. The simple fact really is that with all of the sensors on the cars, our vehicles now know more about our roadway systems than really what we know. Some examples of the available vehicle sensor data are the trajectory of the vehicle, the speed that it's heading at, when it was there, and then also events that occur, whether it's hard braking or hard acceleration. By being able to get this data, we can actually begin to evaluate our network routinely, every day, if you will. Another power of this data is that it's available, honestly, for our entire network. As vehicle sensor data is being installed on more cars, and that data is being packaged up, the big data becomes more available for the entire network. This is insight that we've never had the opportunity to get before. So this really changes our approach to performance management. Instead of waiting for accident data, we can now see how vehicles are performing in a manner that is very close to real time for the entire network, and not just the state network, or not just a component of the network that we choose to collect data for. Another potential innovation is the use of AI to evaluate that vehicle sensor data. AI is quickly evolving to be able to give engineers the ability to leverage those tools to be able to make decisions faster. So in this example, the integration of the AI with the vehicle sensor data allows us to perform real-time incident management. The AI can detect incidents on the highways before the queue builds up. We can program it to inform respective stakeholders about the growth of the queues. And we can have the AI begin working on diversion strategies for our engineers, and also to be able to create alerts for motorists of the potential risks to hopefully prevent secondary crashes. If you look at the chart that I'm showing here, you can see that queuing was created by a vehicle engine fire initially. In this example, then a secondary crash occurred because of the queuing that was created by the first incident. These are the types of things that faster response through the power of vehicle sensor data and the power of AI analysis of that data could hopefully help us improve our ability to respond. Vehicle braking has long been a good indicator to highlight opportunities for improvement to trouble spots. Vehicle sensor hard braking data is more scalable and better than the old method of going and trying to find skid marks on the pavement. In work that we've done with Purdue University, research has been able to find that statistically there's a direct correlation between hard braking events and crashes. The ability to analyze the hard braking data allows us to be much faster at responding to areas of opportunity. Another area where innovation is allowing us to evolve quickly is with our work zone management. By integrating hard braking data with routine UAS imagery collection, we can evaluate work zone performance in entirely new ways. This is an example segment of roadway, and this is the hard braking data that we collected prior to setting up the work zone. Now this shows the hard braking data after the work zone was set up. As you can see, there was a 7.5 times increase in hard braking events at a location of bifurcation that was created for the work zone. There was a separate location where we had vehicles merging, and there was almost a 4 times increase in hard braking events at that location. Here I have UAS video showing what is happening at the merge point. As you can see, the gray car trying to merge on is confused about how to interact. You see a hard braking event happen right behind the gray car. And so this vehicle, rather than utilizing the available merge area, they stop at the end of the ramp. And so this allows us to look into what the drivers are seeing and understand better what concerns they have or what lack of understanding they have of how they're supposed to properly merge in that area. Potential mitigation opportunities would be to provide more driver signage awareness so that they understand how they are supposed to navigate this merge point. This is that same area where we have the aerial map of this area with the hard braking data superimposed on the map. So in the hard braking data, you can see the event clusters shown at the merge. So it's not just that one driver that is having trouble navigating this merge point, but numerous drivers are having the same issue. So this data can be used for real-time assessment of the safety performance of that area. The other power is that once the mitigation strategies have been implemented, the connected vehicle data can be reviewed and the mitigation strategies can be evaluated immediately. As we continue this iterative process of assessment and mitigation and reassessing, we're able to iterate our way towards a better performance for that area. So in summary, I'd like to thank you for this opportunity to share information about our INDOT Safety Performance Program. The foundation of our program really are the principles of leadership, assessment, and mitigation. These three core activities are performed in a perpetual series to allow the program to evolve. Innovative tools and techniques are rapidly coming to market that are allowing us to improve our ability to achieve our goals. Thank you so much and have a great day.